I can identify and determine the probability of two dependent events. Signal words for dependent are not replaced, not returned, eat or eaten, set aside, and especially disappear. Dependent stands for the D if something disappears, or if the bottom number in your probability calculation changes. So let's look at this first example. A bag contains 10 marbles and 2 white marbles, 10 blue ones and 2 white ones. Kamarian picks a marble from the bag, sets it aside, and then picks a second marble from the bag. What is the probability that he will select a white marble and then a blue marble? Well, we know he's choosing twice right here. And if we have 10 blue marbles and 2 white marbles, of course, we start with 12. But he sets it aside. So that means after his first choice, the bottom number has to change to 11. Then he's looking for a blue marble, and there are still 10 of those available. So if we multiply in our calculator across, we're going to do the numerators on one line. I'll go ahead and show you how that works. 2 times 10. Then we'll do the denominators on a second line. That's because we are looking for a fraction. If you'll notice, I got 20 over 132. Well, this is showing you here how to simplify using your calculator. So I'm going to take the top number, the numerator, divide it by x. I'm going to take the bottom number, the denominator, and divide it by x. And my x begins with my numerator, which is 20, the top number. I want these two numbers here to have no decimals. If they have decimals in them, then that is not correctly simplified. Let's try 19, 18, 17, 16. Notice these all still have decimals. So I'm going to have to keep going until they're both whole numbers. Okay, I'm going to have to go down to 9 because we haven't seen any yet. 8. I know that you want to go quickly, but go ahead and just take your time so that you don't miss the answer, which is right there at x equals 4. The fraction for this probability is 5 out of 32. So let me go ahead and write that for you. 5 out of 32, or 33, excuse me, opportunities. Now I need a decimal. Well, that's not going to be hard at all, but personally I'm going to come up here to the top and look at my first two numbers, 20 over 132. To make sure I didn't make a mistake when I was simplifying, I'm going to take 20 divided by 132, and that gives me a repeating decimal of 15, or excuse me, 0.15, and it just keeps repeating. So to check to make sure I simplified correctly, I'm going to go ahead and put 5 divided by 33 in the calculator, and yes, those two are the same. Now I need a percent. That can easily be done by multiplying by 100, and that gives me a percent of 15%. So the probability of this happening is approximately 15%. All right, here's a problem we need to go through. A random or a marble is chosen at random, then it is set aside so I know that something's going to change. That bottom number is going to change, so I need to remember that. Then another marble is chosen. What's the probability that a white marble is chosen first? So first we need to count all the white marbles. 1, 2, 3, 4, 5, 6, 7, 8. and I always count twice to make sure I don't make a mistake. Then followed by a black marble. So let's count the black marbles. 1, 2, 3, 4, 5. So I'm going to put a 5 there. But I need to figure out how many marbles I started with. Well, I had 8 white. I had 5 black. Let me count and see how many gray I have. 1, 2, 3, 4, 5, 6, 7. So I'm going to add 7 to that, 5 and 8. So that tells me I had 20 marbles to start with. So when I made my first choice, I was looking for 8 white marbles out of 20 possibilities. But then I set 1 marble aside. That means I only have 19 left when he tries to find one of the 5 black marbles. So since it's asking me for a percent rounded to the nearest tenth, I'm going to go ahead and put this all on one line. 8 divided by 20 times 5 divided by 19 times, we want it as a percent, we multiply by 100. So my answer would be, and rounded to the nearest tenth, would be 10.5%. That's the probability that those two things will happen. Now we're going to identify each situation as independent or dependent. Independent means it doesn't change. Rolling a dice, flipping a coin, putting something back, spinning a spinner. Dependent means something has disappeared, something has changed. So let's look at the first scenario. There are 5 fiction books on a shelf. 3 are nonfiction books. Someone chooses a fiction book and then leaves. The next person chooses another fiction book. Well, the hint is right here. They take a book and they leave. So that means a book disappeared, so it is dependent probability. Next one, spinning a spinner and landing on red, then spinning and landing on blue. A spinner is definitely independent because you can spin it 1,000 times and the number of possibilities will never change. Let's look at the next one. The probability of selecting a king from a deck of cards, replacing it, that means putting it back, and then selecting a queen. That would be independent because the number of possibilities did not change each time he was selecting a card. Finally, the probability of selecting a purple marble from a bag, not replacing it, then selecting another purple marble. That is definitely dependent because the first one was not replaced, so it disappeared.